Alaikum wa rahmatullahi wa barakatuh. Okay, guys, very quickly, I'm going to let you get on and watch this presentation done by the physicist. It's about the system, at least the brown dwarf star, which we've said is behind the Earth right now, with a Najm Thaqib sharing a barycenter with our sun. So what we've got is a companion star to one Najm Thaqib, which is a burnt out star, and that seems to have very close proximity to Earth, right? And now we'll just discuss in detail the relationship between the star system of An-Najm Thaqib and all the relative celestial bodies that have that form part of this system, their interaction with the Earth and the Sun, and then the impact of that on the Earth. Subhanallah.
Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X researcher and professional physicist. Today I'd like to discuss with you my newest article, and it's to do with the Becky-Lewis object in the sky. And I will discuss what it is, what I think it is, based on the observation made by Becky-Lewis, and what does it mean for us on the Earth. So this is the first image that Becky-Lewis showed. I know it looks very small. She later zoomed in, and will be able to look at that in the next slide. But Becky-Lewis videoed this object, and for quite some time it didn't seem to be moving. Now, it's possible that it was moving, but very slowly. And any object that keeps to a stationary position with respect to a fixed position on the Earth's surface can only be orbiting the Earth. Don't forget that background stars move in the sky because the Earth is rotating. The Earth is rotating, rotates 360 degrees in 24 hours, which means that the background star should be moving about 15 degrees per hour. Now, so this object is not with the background stars because it keeps stationary. And that means only one thing: it has to be in an Earth orbit. And in fact, it has to be close to the geosynchronous orbit or altitude, which is about 36,000 kilometers above the surface of the Earth. Now, it could have been moving slightly, and it may not have been obvious in this video. So it may be slightly above that, but not by much, because it does not seem to be moving very much. The object also emits its own light, so it does not seem to be reflecting light. It seemed to actually be flickering, almost like a flame. And a flame is, of course, plasma. So this object was obviously made out or creating plasma by ionizing some gas and emitting light as a result. An object that emits its own light is, of course, a star. And the color of the object was reddish, dark orange, and that would indicate a temperature of about 3000 Kelvin. Now, a close-up or a zoomed-in image of the object, we start to see what it actually is, and we can actually see that it is a cloud of gas, and it's emitting red light. And it actually seems to have a hole in it, and through the hole we can see the bright light inside its center. Now, this is characteristic of course, a brown dwarf star. A brown dwarf star ionizes its cloud of gas, and we would see the hot glowing core inside, because it has a core and it's surrounded by a cloud of ionized gas. And it first has a cloud that is denser and close to the core, and that's called the envelope, and it usually forms a thick ring. And the thick ring may therefore have a hole in it, like we see this cloud has. Now, this object is obviously emitting bright light from the core, so it's probably having fusion reactions from the surface, which is producing this orange color, a bright orange, which is again indicates about a temperature of 3000 Kelvin. Now that's an even closer zoom of the image, and here I explain what brown dwarf stars. They are, of course, um, old stars that have gone through the red giant phase and the white dwarf phase before cooling. And they start going through this, what I call the aging process, when their energy starts running low, and they then are no longer able to hold on to the cloud of ionized gas like before. So they start releasing it. They first turn into a huge star, a red giant, and then they release the layers completely, and we are left with a small core, an envelope around the core, and a more diffuse cloud outwards from the core of the object. So these objects release these layers of gas that were actually part of the surface of a star, and so these clouds are of course able to become ionized again and start producing like they did on the star itself. Now these objects, when they come into the solar system, seem to only emit infrared radiation, so they're not visible to us because they do not emit visible light. They can only be seen if observed through an infrared telescope. But they seem to then absorb energy from the sun and start being able to ionize their cloud of gas, which then starts emitting light, and eventually the core becomes ionized to the point where you can start having fusion reactions from the surface, and it's called fusion reactions, not hot fusion. So it's powered by the internal electric potential energy of the object. And eventually the light emitted from the core, because it's due to these fusion reactions, is brighter than the light emitted by the cloud. Now, what does it mean that this object is so close to the Earth? Because if this object is in orbit around the Earth, now the geosynchronous satellite altitude is quite far, 36,000 kilometers. Don't forget that the ISS is only at 400 kilometers, much closer to the surface. So it's still reasonably far away, but it will have effects on the Earth. First of all, the fact that this object may actually be in orbit around the Earth means that brown dwarf stars do not just attract or are attracted to main sequence stars like I have observed, that these brown dwarf stars are attracted to the sun. They attach themselves magnetically to it, and so they remain close to the sun. So if this object is actually close to the Earth, it means that brown dwarf stars can also attract or be attracted to planets and magnetically attach themselves to planets. Now, if this object has attached to the Earth, and because these objects absorb energy from whatever object is in their vicinity, this object may be absorbing the Earth's internal energy, and this may lead to the Earth's magnetic field weakening or decaying. And this is what we actually have observed. Not only will this object interfere with our magnetosphere, and hopefully it's not actually inside our magnetosphere but outside, but either way it will impact our magnetosphere from different directions and therefore weaken and put extreme pressure on our magnetosphere. Also, this object would attract stronger solar activity from the sun, because it would basically, at least at some points in its orbit, the Earth would be right between it and the sun, and it magnetically attaches to the sun and therefore draws the sun's magnetic field lines and draws this strong activity. And of course this activity would impact the Earth and may lead to cataclysmic events in several parts of our planet. Now, what happens is these objects, because they connect magnetically to the sun, can cause and increase the size of coronal holes and can also strengthen the activity of sunspots. And here we see a large coronal hole facing the Earth, and we've seen these coronal holes many times. As they rotate, as the sun rotates, the coronal hole rotates with it so that eventually it faces the Earth, and they seem to actually grow as they rotate towards facing the Earth. And that would lead to an increase in the amount of fast solar wind impacting the Earth. Now, sunspots may also become more active when they face the Earth because of this object being so close to the Earth. And that would lead to the increased chance of solar flares and CMEs released by sunspots when facing the Earth. And it would also lead to increased strength of solar flares and increased strength of CMEs. And this picture here shows some sunspots on the solar surface. As you can see, there are deep holes inside the surface of the sun. This is the photosphere. This is the part of the sun that is at 5,800 Kelvin, and from which light from the sun, visible light, is emitted. Now, these diagrams explain or illustrate how the strong magnetic field of an object like a brown dwarf star in orbit around the Earth. So here's the Earth, it's in orbit around the sun. Here's the sun. This would be the Becky-Lewis brown dwarf star, and this would, here it's in the position where it would have the strongest effect on the Earth. If there is a coronal hole facing the Earth, then the magnetic field lines coming from the sun would be pulled right out of the surface of the sun, so they're about perpendicular, and would then close at this object. They would attach to the magnetic field of this object. And that leads to a coronal particles spiraling along the magnetic field lines and moving away from the sun's surface at extremely high speeds, and so we would get fast solar wind impacting the Earth, and we will also get lower density in the sun's corona, which is then looks like in ultraviolet light like the 21.1 nanometer. It looks darker. And it would lead to actually the coronal hole growing, because the strength would be the strongest effect of this brown dwarf star on the coronal hole would be when the coronal hole would be facing the Earth. Now, something similar happens with sunspots. So here we have a sunspot, and sunspots have strong magnetic field lines very close to each other. So very strong magnetic field surrounding these sunspots. And of course, the fact that we have an object with a very high magnetic field facing the sunspot, it would interfere with that magnetic field. It would pull on it and therefore possibly lead to more intense solar flares and CMEs in the Earth's direction. Now, on July 14th, the coronal, I meant the sunspot AR2665 fired a class M2.4 solar flare in the Earth's direction. Not directly, but it was in a direction where Earth would be impacted. It was a large CME, and what led up to a CME was the solar flare. What we see here is the CME. So we first had the solar flare. It was class M2.4 solar flare. It's quite strong solar flare, and it was long lasting. So it arrived on Earth 8 minutes later because it travels at the speed of light, and that created an S1 solar storm which interferes with radio communications. It also leads to the ionization of our ionosphere, and it leads to electron currents in the ionosphere, which in turn induce currents further down into the Earth's atmosphere and inside the Earth and on the surface of the Earth. Now, after the solar flare came the high energy proton flux, and that is basically cosmic rays, because these protons travel so fast at about 1/3 of the speed of light or even greater. If they were traveling at 1/3 the speed of light, they would take 30 to 40 minutes to reach the Earth, and that speed corresponds to about 62,000 miles per hour. And this would also ionize the ionosphere and lead to an increase in electrons and currents. And the effect would, of course, last a few days. Now, this sunspot group AR2665 had earlier, before it faced the Earth, had an M-class flare. It was an M1 class flare. So when it faced the Earth, it had an even stronger solar flare. And this would go along with the fact that this object is close to the Earth, and therefore it leads to stronger solar flares when the sunspots face the Earth. Now, as a result of the CME being released on July 14th, it actually reached the Earth 2 days later. Now, that indicates that this CME was also associated with fast moving particles, because usually CMEs take 4 days to reach the Earth. This one took 2 days. And we see here when this is actually the shock wave associated with the solar flare, which arrived earlier on the 16th, and this is about 12:30. That was 12:34 UTC, and we see the bow shock here being compressed by density, and it's pushed back behind the geosynchronous orbit. You also see it being bent here on the night side. To me, that's always associated with the fact that there is an object behind the Earth. It may be that it is due to this object that is in orbit around the Earth and is causing the bow shock to bend, as if it's facing stellar wind from that side. Here we see the electrons, the high energy electrons coming in towards the Earth. As you can see that the red color is not even on the scale, it's above the scale. So this indicates a radiation hazard. And at the time, the KP index was 6, showing geomagnetic storm conditions of moderate strength. And these electrons would then spiral towards, along the magnetic field lines towards the north and south poles and populate, well, most of them, not all of them, some would impact the ionosphere and lead to currents. Some would actually go into the lower atmosphere. And so these would populate the aurora ovals and lead to aurora down to mid-latitudes. And then a little later, we see what starts to happen as the shock wave hits. The bow shock actually is gone. The magnetopause seems to collapse completely, and we have extremely high speed solar winds. So we see here the speed is 2559, which is unheard of. Usually fast solar wind is about 1000 kilometers per second. This is way above that, 2559 kilometers per second, which is the same or as 5.7 million miles per hour. This is unheard of. It's amazing. Now, why would we get something like that? Well, our bow shock actually seemed to collapse completely, and the solar wind is slowed down at the bow shock. Without that barrier there is nothing to slow down the solar wind particles. So they come in at extremely high speeds. But even so, the speed that we obtained here is way beyond anything we've seen before. Now, these particles would have streamed into the magnetosphere and into the atmosphere, and therefore create intense radiation hazard for people on the surface of the Earth, and especially for people in airplanes. And here we actually see the bow shock.
This also explains the migraines, the lethargy, the joint pains, the general depressive state of mind that people have been experiencing of late, especially recently, and the extra UV radiation as well. In fact, it's way above the charts. The charts only go up to about 11, I understand. We've been recording UV radiation at 13, which is just, well, it's not even on the charts. So that's how extreme that is and how harmful that is. Subhanallah, very Ajib things are happening all over the globe. You know, we've seen all the seismic events increasing. Now you've got what they call the God Mountain in Tanzania, which is about to erupt. Please score a line underneath that and don't take my word for it. You'll find it on Google. And these are recent events. In fact, world over, all these volcanoes have become very active this Islamic year, subhanallah. And then we've got the floods. I mean, look, in India just right now, this is today's again. I think I've shared it with you guys on the science distribution list on WhatsApp as well. We've seen people being relocated, 1 million plus, because of the floods. But then the floods haven't stopped there. They're in the States simultaneously, in China as well, all at the same time, by the way, and other locations. In fact, as I understand it, Quebec has basically experienced snow in July. Which is unusual to say the least. So I mean, we've got these extreme weather patterns all over the globe in every region, subhanallah, whether it's extreme heat or extreme cold, or whether it's these floods or seismic events. We're just seeing everything all at the same time, simultaneously happening all over the globe, and it's getting worse. It's getting far more extreme. It has been. I'm sure the guys and those of you who've been following the science distribution list have also noticed the same. It's not incremental, it's exponential at the rate at which all of these extreme events are increasing, and they're not abating. They're not showing any sign of abating. The sun's getting weaker and we're getting into more problems. Allah subhanahu wa ta'ala knows best, but I certainly believe that this system will be the Asbaab, and Allah subhanahu wa ta'ala knows best for the three great landslides.
Line, and we see what happened to it. This is from 1246, and we see it just blown completely away from being in front of the Earth. And this shows a complete collapse. Here it's bent in the wrong direction. So this is very surprising. It shows that our magnetosphere is under intense pressure, and it just did not cope with this fast moving CME. And this is what happened. And of course, radiation would have flooded into the Earth's atmosphere at this time. Now, the effects of the increased ionization of our ionosphere can be dramatic, and we've seen it happening and increasing over several years now. We are getting more and more earthquakes, more and more volcanic activity. But what happens is we get increased currents in the ionosphere, and these currents induce currents lower down in the atmosphere, on the surface of the Earth, and inside the Earth. And the ones in the atmosphere will lead to severe weather patterns and power grid problems, possibly transformers blowing up, and the currents inside the Earth would lead to increased earthquake and volcanic activity. And of course, this is extremely dangerous. It's increasing. It can lead to cataclysmic events. A really large volcanic eruption can lead to a lot of dust in the atmosphere, which will block sunlight from reaching the surface. It will block photosynthesis, and it would lead to it could be an extinction level event. Let's put it that way.
Guys, again, this, sorry to interject again, but what she's just described could be one of the possible asbab for a dukkan again. We can't obviously discount that. I understand that this system itself has got other helium clouds with it. So, I mean, again, that smoke could come from there. Allah subhanahu wa ta'ala knows best, but it seems like this system may very well be the asbab for a lot of hadiths to come into fruition. At least it's plausible to think that it could be. Right? And what we understand, and at least my position is that it will happen like a string of pearls. Allah subhanahu wa ta'ala knows best again.
Um, and a huge earthquake can also cause major disruptions to different parts of the world. It can lead to tsunamis that can destroy whole cities if they are large enough. And we've seen that happen in Japan already. So,
and we had a tsunami today, a tsunami warning in Russia as well, with the 6.6 magnitude earthquake, subhanAllah. But then all of this was just posted by the physicist. She's just come onto the scene very recently, by the way. The other researchers, including myself, have been studying this phenomena for many, many years. But it's interesting how the physicist is basically, if you look at the science PDF, which was uploaded almost a year and a few months ago, you'll find that we had the same position back then as well. Right, you'll find that we maintained the same position back then as well, and she obviously she's outlining exactly the same as what we've hypothesized in the science PDF. Subhanallah.
These are what could happen to our planet. I don't see this object coming any closer. It may actually be in a stable orbit, and it, however, will impact the Earth, and it will attract severe space weather from the sun itself. So these are the dangers that we face as a result. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.